The creation of the Tiger II begins long before its formidable silhouette takes shape. It starts with raw steel, massive slabs arriving at the factory, hauled by cranes and stacked beside roaring furnaces. These plates are the foundation of one of the most heavily armored tanks ever built. Inside the workshops, extreme heat transforms cold metal into a malleable force. Furnaces glow bright orange as workers feed the steel, preparing it for the brutal compression of hydraulic presses. With tremendous force, each press shapes the armor plates that will soon form the lower hull, giving the Tiger II its legendary resilience. As the plates cool, machining teams refine every edge with millimeter precision. Sparks trail across the workshop floor as cutting torches and grinders sculpt thick armor sections. The lower hull assembly begins on vast platforms, where workers maneuver enormous components using chains, clamps, and guiding rails. Welders seal each panel with thick lines of molten metal, reinforcing the structure to withstand enemy fire and the weight of the Tiger's massive turret. The base of the tank slowly emerges, a sturdy armored box built to carry tons of steel, machinery, and firepower. The process is slow, methodical, and unforgiving. Every seam, every weld, every plate must endure unimaginable stress. This is the Tiger II's first breath, the moment when raw steel becomes the foundation for one of the most feared machines of the Second World War. The Tiger II's identity truly emerges in the second stage of construction, where its iconic angled armor takes shape. After the lower hull is completed, massive steel plates, some over 150 mm thick, are transported into the assembly hall. Each plate has already survived forging, heat treatment, and machining, but now the challenge shifts to precision alignment. The Tiger II's armor wasn't just thick, it was engineered with carefully calculated angles designed to deflect incoming fire. This meant every panel had to meet its neighbor with absolute accuracy. Cranes lower the heavy armor slabs into position, while teams of workers guide them by hand, using crowbars, clamps, and chalk markings to secure perfect alignment. Even a few millimeters of deviation would compromise the structural integrity of the hull. As sparks fly across the workshop, welders begin sealing the armor with deep penetrating welds, each pass strengthening the massive defensive shell. The process requires immense skill. Thick armor demands controlled heat, precise timing, and clean seams to avoid internal weaknesses. Gradually, the upper hull forms around the tank's skeleton. The sharply sloped glassy plate, one of the Tiger II's most distinctive features, is fitted into place, an intimidating shield capable of stopping most Allied rounds of the era. Workers reinforce the joints with layered welds and internal bracing, creating a rigid and interlocked structure. Inside the workshop, the giant armored box begins to resemble the powerful machine that would soon dominate European battlefields. With every plate secured, the Tiger II becomes more than a collection of heavy steel parts. It becomes a fortress on tracks, crafted through extreme precision and sheer industrial strength. By the time the angled hull is complete, the tank already embodies the fearsome reputation it would earn on the front lines. The Tiger II's transformation accelerates when its massive turret enters production. Forged from thick slabs of hardened steel, the turret begins as a rough, box-like structure before being shaped into one of the most formidable armored components of the entire war. Workers position the curved front mantlet plate, a section so thick and heavy that only overhead cranes can maneuver it, while machinists prepare the mounting rings for the Tiger II's deadly 8.8 cm KWK-43 cannon. This gun, with its extraordinary velocity and armor-piercing power, required not only engineering excellence but an exceptionally strong foundation to support it. Inside the workshop, the turret walls are welded together with the same precision applied to the hull. Each weld is meticulously layered to handle the tremendous stress produced when the main gun fires. Meanwhile, technicians install the internal framework, seating mounts, gear mechanisms, elevation controls, and rotation components. The turret's traverse system, a carefully engineered set of hydraulics and gears, allows the Tiger II to rotate its heavy guns smoothly even on uneven terrain. The heart of the process arrives with the assembly of the cannon. The long barrel is forged, rifled, polished, and heat-treated before being carefully aligned through strict tolerance checks. Once mounted, workers secure the breech block, recoil cylinders, and loading mechanisms, creating a weapon capable of destroying enemy armor at extreme ranges. When the turret is completed, it becomes a self-contained combat platform, heavy, complex, and meticulously engineered. The moment it meets the hull is one of the most impressive scenes of the entire Tiger II production. A massive crane lifts the turret high above the assembly line, the steel giant hanging in silence before being lowered onto the turret ring. Workers guide it into position, locking thousands of kilograms of armored power into place. Inside the Tiger II, the most complex systems begin to take shape as engineers install the components that will bring this steel giant to life. At the center of the assembly hall, the massive Maybach HL230 engine is prepared for integration. This 12-cylinder, liquid-cooled powerhouse was originally designed for heavy armored vehicles, but even for the Tiger II, it operated at the limits of its capabilities. Workers carefully mount the block onto reinforced supports, securing fuel lines, cooling systems, and exhaust channels engineered to withstand extreme battlefield demands. Nearby, the transmission and final drive assemblies are meticulously constructed. These are some of the tank's most intricate mechanical systems, responsible for converting raw engine power into controlled, reliable movement. The transmission is fitted with precision-machined gears, shafts, and clutches, each calibrated to synchronize with the Tiger II's tremendous weight. Mechanics synchronize the steering brakes and differential gears, ensuring both agility and stability despite the tank's massive size. As the engine compartment takes shape, electrical systems are routed throughout the interior. Wiring harnesses snake along the hull walls, supplying power to ignition circuits, communication systems, lighting, and turret controls. Every cable must be heat-shielded and shock-resistant. Battlefield vibrations could easily tear poorly mounted wires apart. Inside the fighting compartment, technicians install the driver's seat, control levers, and instrument panels. Gauges for temperature, fuel pressure, and engine performance are aligned with military precision. The radio operator station is equipped with communication equipment essential for coordinating armored assaults and receiving real-time battlefield orders. Fuel tanks, coolant reservoirs, and lubrication systems are secured in place, forming the circulatory network that keeps the Tiger II running under harsh combat conditions. Inside the Tiger II, the final elements that define its combat effectiveness begin to take shape. While the exterior armor and mechanical systems give this tank its imposing presence, it is the internal layout, designed for 5 crew members, that determines how effectively the machine can fight. Workers begin by fitting the loaders and gunners stations inside the turret. These cramped spaces are organized with precision. Ammunition racks are mounted securely along the inner turret wall, allowing the loader to access heavy 88mm shells under the stress of battle. Each shell is positioned carefully, its casing polished and inspected for imperfections that could jam the weapon or compromise accuracy. In the hull, the drivers' and radio operators' compartments are finalized. The driver's controls, steering levers, foot pedals, gauges, and gear selectors, are calibrated for responsiveness despite the tank's massive weight. Adjacent to him, the radio operator's workspace is assembled. Technicians install the FUG-5 radio, one of Germany's most advanced communication systems of the era. Its wiring is routed through the interior walls, shielded against heat and vibration. This system allowed Tiger II crews to coordinate with infantry, other armored units, and command posts, an essential advantage in rapidly evolving battlefield conditions. Next, interior lighting, fire suppression systems, and emergency equipment are secured. The turret floor is fitted with its rotating basket, enabling gunner and commander to turn with the turret without tripping over the machinery below. Seats are mounted, armored periscopes are installed, and viewing sights are aligned to ensure optical clarity even under harsh conditions. Finally, technicians test the coaxial machine gun, the ammunition feeds, and the communication lines connecting every crew station. The crew's environment is now claustrophobic but meticulously designed, every inch optimized for survival and efficiency. With the Tiger II structurally complete and its internal systems fully assembled, the tank moves into the final stages that will prepare it for combat. The first step is the application of its protective coatings. Workers clean the entire exterior hull, removing grease and residue left from welding and machining. Once the steel surface is prepared, a thick base coat of anti-corrosion primer is sprayed across the tank. This primer protects the heavy armor from moisture, debris, and the extreme conditions it will face on the battlefield. After the primer dries, specialists begin applying the Tiger II's distinctive camouflage. Germany's late-war patterns vary depending on region and factory, but most Tiger II's received combinations of dark yellow, olive green, and red-brown. Using both spray guns and large brushes, workers create flowing, irregular shapes designed to break up the tank's massive outline. These patterns were meant to blend into forests, fields, and war-torn urban environments. Some sections receive extra coats of textured paint to improve concealment and reduce sunlight reflections. Once the camouflage is complete, identification markings are added, turret numbers, division emblems, and crosses painted with military precision. Each unit uses slightly different configurations, and these markings help commanders track their armored groups in the chaos of combat. With its exterior finished, the Tiger II rolls into the testing grounds. Mechanics and engineers conduct a series of rigorous trials to ensure the tank is ready for deployment. The engine is pushed to maximum output as the tank climbs steep hills and accelerates along rough terrain. Suspension systems are monitored as the Tiger II crushes obstacles, crosses trenches, and maneuvers over uneven landscapes. The turret is rotated through its full range, while the 88mm gun is elevated, depressed, and locked into firing position. With the Tiger II fully assembled, painted, and tested, the final phase of its journey begins, preparing the tank for deployment to the front lines. In this stage, every system undergoes meticulous final inspections. Mechanics verify torque settings on suspension components, tighten armor bolts, and recheck the transmission and steering linkages. The massive Maybach engine is run once more under controlled conditions, ensuring stable temperatures, smooth ignition, and consistent power output. Any irregular vibration or fluctuation is corrected immediately, because once the tank leaves the factory, battlefield conditions will allow no margin for error. Technicians inside the hull and turret run through communication checks, testing the FUG-5 radio system and the intercom setup that links all crew positions. The gunner aligns optical sights, while the loader secures training rounds to ensure smooth handling during combat operations. The commander's cupola periscopes are cleaned and adjusted to guarantee maximum situational awareness. Next comes logistical preparation for transport. A Tiger II is far too large and heavy to simply drive directly to the front. Workers begin by loading essential spare parts, track links, tools, cables, and repair equipment, onto support trucks. Fuel drums and lubricant containers are gathered for the armored column that will accompany the tank. Ammunition crates are inspected, sealed, and labeled. High explosive shells, armor-piercing rounds, and machine gun belts are all organized for the battalion supply teams. Finally, the Tiger II is moved toward the rail platform. Special reinforced railcars, designed to handle the tank's extreme weight, wait on the loading track. Ramps are secured, and the Tiger II is carefully driven up the incline. Its tracks lock into steel braces, and workers secure chains to prevent movement during transport. The journey from raw steel to battlefield titan is now complete.